Hey class, so we're going to be learning about absolute value functions. Absolute value functions, they represent distance. A distinctive thing about absolute value functions is that they have, or they form a V-shaped figure on an X and Y axis. Okay, so to give you an example of an absolute value, I'm just going to go ahead and draw an X and Y axis. Now, a good way to graph any function is create a table. So I'm going to create a t-table right over here. We're going to have x, and I'm going to put f of x. An absolute value is typically known as f of x equal to absolute value of x. Okay, this is the parent graph, and we're going to see how that looks like on this axis. So in order to graph, you can pick any inputs. I'm actually going to pick inputs from -2 all the way to +2. Okay, and plugging that in, if we plug in -2 into this, we're going to receive our output. -2, or the absolute value of -2, is actually a +2, -1, +1, 0, 1, and 2. Right? Anything you plug in into an absolute value function is going to be positive. It's just a positive version of any number. Okay. Now these gives us coordinates that we can graph on our plane. So the first coordinate is -2, 2, which is 2 to the left and 2 up. Right there. The next one is -1, 1, which is 1 to the left and 1 up. We have 0, 0, 1, 1, and 2, 2. Okay. Notice how it forms this V shape. I'm just going to go ahead and if this pattern were to continue, it would create something that looks like this. And that is the parent graph of an absolute value function. Now with this, there are numerous things that you can change about this. There are numerous things that you can translate, you can dilate it, and I'm going to show you how to do that. So right here, this is the form of an absolute value function. We have f of x equal to a absolute value of x minus h plus k. These values here, a, h, and k, they do something to our parent graph. Typically, we'll start with our parent graph and perform different transformations to it. But let's go ahead and explain what these things actually do. We're going to start with the a value. What the a value does is it actually dilates this V-looking shape. And what I mean by dilate is that it determines whether it faces up or down. It can stretch it, it can do a vertical stretch, it can do a vertical compress, or even reflect it. It reflects it if that A value happens to be negative. Okay. The next thing is the H value. The H value here is that this shifts the V shape side to side. The thing is we should note is that it's typically the opposite. And we'll work this out on an example coming up. But let's say this, like if we had x plus 3, you would think you would move to the right 3 since it is positive, and on a number line you do that. But it's actually the opposite. You'd move to the left 3. So if this were x minus 2, the opposite, instead of moving to the left 2, you'd move to the right 2. And finally, the last variable that we have yet to define, which is the k value. What this does, this moves a function vertically, moves it up and down. Okay, so this, no opposite happening here. If this is +5, up 5. If this is -2, down 2. Okay. So what we're going to do is we're actually going to use these right here and graph these functions in relationship to this. Okay. So we're going to go ahead and start with f of x equal to negative and then the absolute value of x. Essentially what this does is you can look at the different points here, right? And we got that from the parent points, right? Just using a t-table and plugging it in. Essentially in order to get this new graph is you just kind of measure the distance, or the height those points are from the x-axis. Okay, notice how at this point right here, it has a height of 1. Now multiply that with our a value, you can think of this as a -1. Okay, 1 times -1 is -1. So instead of going 1 up, it goes 1 down. Okay, here, +2, well it's now -2. +3, -3. right here at the vertex, it's on the origin currently. That height is 0, so it remains there. Okay, but same thing happens here. We're gonna get this upside down V looking shape, and that is the function of negative absolute value of x. Okay. The next one we have is g of x, and this is a horizontal shift, so it's still left and right. We talked about that you actually want to graph in the opposite direction. So absolute value of x minus 4, that's actually going to change this 4 to the right. Okay, so what we would do is we would have units here, you have little tick marks. I typically like to move the vertex, so we can move this point, 1, 2, 3, 4. So that new point is right here. And you can do that to all these other points. But for this function, we have this right here. Just very, very loosely, that's what it looks like. Okay. And the last one is absolute value of x plus 2. For this is a vertical translation, so we're actually going to be moving this up 2. So trying to ignore this red and this blue function, we're going to translate this black function up 2. So moving this vertex up 2, the vertex is now here, and if you shifted all the other points, what would happen is that you would get something that looks like this. You can visually see that this is moving up 2. Okay. I think that's pretty much it. So this is how to translate an absolute value function.